Good morning to everyone. I am Dr. Sumi MS. The name of the course is Electromagnetic Fields and today's lecture topic is Maxwell's equations. On completion, the students will be able to state 4 Maxwell's equations, list down the applications and the advantages and disadvantages of Maxwell's equations. Maxwell's equations. Maxwell's equations are like the instruction manual for how electricity and magnetism work. They were created by a smart scientist named James Clerk Maxwell in 1800. Since these equations help us understand everything from how lights work to how our gadgets and technology function, they are extremely significant. Maxwell's equations describe how the electric field can create a magnetic field and how a magnetic field can create an electric field. Evolution of Maxwell's equations. Back in the 1800s, people were trying to figure out how electricity and magnetism were created. Scientists like Michael Faraday and Andre Marie Ampere made discoveries that made Maxwell thinking. He put together their ideas and made 4 special equations that explain how electricity and magnetism are related. 4 Maxwell's equations. The 4 equations of Maxwell are Maxwell's first equation that is based on Gauss law, Maxwell's second equation based on Gauss law on magnetostatics, Maxwell's third equation based on Faraday's law of electromagnetic induction, and Maxwell's fourth equation based on Ampere's law. Here comes the 4 laws of Maxwell's equations. Maxwell's first equation. Maxwell's first equation is based on the Gauss law of electrostatics. This law states that in a closed surface, the integral of the electric flux density is equal to the charge enclosed. The expression for Maxwell's first equation can be expressed mathematically as del dot E dV is equal to rho V. Maxwell's second equation. Maxwell's second equation is based on Gauss law of magnetostatics. This law states that the sum of outer flux in the magnetic induction through any closed surface is 0. This expression can be given mathematically as del dot H is equal to 0, where H represents the magnetic field. Maxwell's third equation, it is derived from Faraday's laws of electromagnetic induction, which states that the line integral of magnetic field in a closed circuit is equal to the closed current. From this, we can obtain the expression mathematically as del cross E is equal to dou B by dou T. Maxwell's fourth equation is derived from Ampere's law, which states that the magnetic field divergence is always 0, and the expression for Maxwell's fourth equation can be expressed mathematically as del cross H is equal to dou D by dou T plus J. Applications of Maxwell's equations. There are many applications and uses of Maxwell's equations in the field of electrodynamics. The equations act as a mathematical model for electric, optical, and radio technologies such as power protection, electric motors, wireless communication, radar, etc. They describe how charges, current, and field change produce electric and magnetic fields. According to Maxwell's equations, a changing magnetic field always produces an electric field, and similarly, a changing electric field can induce a magnetic field. Advantages of Maxwell's equations. Maxwell's equations show the connectivity between the theory of electricity and magnetism. Various electromagnetic phenomena like the propagation of electromagnetic waves induced, including light behavior of electric circuits, were predicted and explained by Maxwell's equations. These equations form the foundation for classical electrodynamics. They are also necessary to comprehend how electromagnetic fields are produced by charges and current. And the emergence of light as an electromagnetic wave paved the way for the development of technologies like radio, television, and wireless communication, and this was made possible by Maxwell's equations, which predicted electromagnetic waves. Modern physics rely on Maxwell's equations, which have influenced development of other theories which include quantum mechanics and special relativity. Disadvantages of Maxwell's equations. Although Maxwell's equations are based on the principles of classical electrodynamics, more sophisticated theories are required when applying them to very tiny scales of quantum electrodynamics and high-speed relativistic electrodynamics. Maxwell's equations do not account for quantum effects. Certain presumptions and simplifications, such as the lack of magnetic monopoles and the idealized characteristics of materials, form the foundation of Maxwell's equations. These presumptions might not always adequately represent occurrences that are possible in the real world. And Maxwell's equations are simple, but solving them require complicated geometries and boundary conditions which are challenging. The concepts of gravitational force, quantum mechanics are not included in Maxwell's equations, which constitute a classical theory. Quiz questions on Maxwell's equations. Write down Maxwell's 4 equations. What are the applications of Maxwell's equations? State the advantages and disadvantages of Maxwell's equations. Thank you.